Okay, the problem reads, if 4 moles of a gas at a pressure of 5.4 atmospheres have a volume of 1200 milliliters, what is the temperature? The first thing we have to do is write our knowns and our unknowns. We got to make ourselves a chart. So we have 4 moles, that's our variable N equals 4 moles. We have pressure of 5.4 atmospheres, P equals 5.4. We have a volume of 1200 milliliters, V equals 1200, 1200 milliliters. And we have R, we always know R equals 0.0821 liters atmospheres per mole Kelvin. And remember, that is our ideal gas constant. So those are our knowns. We also have our unknowns, which is temperature. It's asking us for temperature. Okay, now we have to take a look at our units here. We have moles in our R, and we can cancel that with the moles from our N. We are looking for temperature, so we should have a Kelvin left over, the Kelvin coming from our R. Then we have atmospheres that are going to cancel with the atmospheres of our pressure, but our liters are where we're kind of worried here. We don't have liters in any of our given units. We have milliliters, so we're going to have to convert those milliliters to liters so that later when we put everything in the equation, the milliliters will cancel with the liters, and the liters will be able to cancel out, and we'll be left with liters. So we will do 1200 milliliters times 1 liter per 1,000 milliliters. That cancels milliliters on top and bottom and leaves us with liters. 1.2 liters is our new volume. Is the same volume but in our correct units. So now we have to figure out what equation we're going to use. Please remember, we're writing the equation down every time because that's what Ms. Rosinski gives us points for. We don't have anything changing in our gas, which means we're not going to use the combined gas law. We're going to use our ideal gas law. PV equals nRT, PVnRT, as I like to call it. So now we're going to rearrange for T to get T, because that's what we're looking for. So we're going to put T by itself on one side. By dividing by both sides by nr, we have T equals PV over nr. And now we can plug in and solve. We plug in for P 5.4 atmospheres. For V, we plug in 1.2 liters. We'll divide by nr, which would be, N is 4 moles, 4.0 moles, and R is 0.0821 liters times atmospheres divided by moles times Kelvin. Now we'll go through and check that our units are going to cancel and give us what we want. We can cancel our moles with our moles. We have moles on the bottom of a fraction and moles without a fraction. And we can cancel our liters with our liters and our atmospheres with our atmospheres, and that leaves us Kelvin. It's on the bottom of a fraction. That's on the bottom of a fraction. That means we have 1 over k. That's the same thing as 1 divided by 1 over k. And if we're dividing by a fraction, we just flip it and multiply. So that's the same thing as 1 times k over 1, which gives us k. That's how we know our units are correct. So now we can just plug everything in. And when we do 5.4 times 1.2 divided by 4 divided by 0.0821, I don't know if you can see this in the calculator, that bottom line there, we end up with this number. The number of Kelvin, 19.73 Kelvin, is our temperature. And that's it. Rock on. Box your answer and we're done.